So is my screen is visible to all of you? So is it my screen is visible?
Your screen is visible.
Uh, how many are there? Like 52 are joints. Okay, thank you. Hmm.
Just now I got the power. Okay, I will switch on my computer also.
Okay, sir. Okay.
You keep on sharing this screen.
Oh, can I start presenting my screen, sir?
No, no, you present your screen.
Okay. Okay. Now it says strength is 62.
Ensure that everyone is having laptop and software installed.
Actually, we are planning to even want to give the assignments also. So it is better to have the laptop or desktop with your installed software to get the hands-on session successful, and you'll get some concepts. So you think like you're going to have your laptops and desktop with your software is ready. So we'll see some basics using your this Xilinx tool, the programming language. So we are going to use Verila HDL. Site 71, 73.
Yeah, let us wait, ma'am, another 5 minutes.
Okay, okay.
By the time I also switch on my computer.
Okay, sir. Okay. So, welcome to 3-day virtual training on system design using Xilinx Vivado Tool. Thank you for accepting the request and join through this Google Meet. So, ensure that everyone should minimum downloaded your software. There is an alternative option if you want to go for the new version. You can even go for Xilinx, but Xilinx is asking domain mail ID. Domain is nothing but at the rate you need to have your instead of Gmail, and you can log in with any if you are working in industry or in institution. So instead of that, we plan to download your this software, then you can install. New version also you can able to download from the Xilinx site if you want to. So we'll see some basics of Verila HDL followed by the uh, your installation and how to start the session. Tomorrow and day after tomorrow we'll see full-fledged programs using your Xilinx Vivado Tool. So I think all our math history students, mostly all the 76.
రికార్డ్ చేసుకో ఫోటోలు తీసుకోవాలి ఫోటోలు స్క్రీన్ షాట్
Sir, let us start.
Start projecting your screen.
Okay, sir. Sir, is my screen is visible to all of you?
Yes.
Okay. Okay, sir. Sir, can I go ahead?
1 minute. I mean, just I'm starting my computer. It started. I'll get the screen on my PC so that I feel comfortable to teach. Now, meanwhile, all of you go through the Google class. I have shared the material for day 1. All of you verify whether that material is reached in the Google Meet or sorry, Google class. Through Google class, I have shared the material to you. Day 1 material, whatever we are going to get a hands-on practice. Please verify once.
Okay.
So we'll be using that material for the hands-on practice today.
One second, sir. I'll share the Google Classroom ID. One second.
Please ensure everyone should join the Google Classroom. Google Classroom entry and a laptop with software is a must for the training.
class code I posted in the chat box to join the classroom. Try to use this class code. Day 1 material is available. Is the screen is visible too? Is it not? labsources.rar. Try to download.
Aruna ma'am. Yeah, please accept me. Actually, I logged in now into the Google Meet.
Okay,
To my
I
computer.
didn't get any request, sir. Try to join the Google Classroom by using the class code which is I posted in the chat box. Can I stop sharing my presentation, sir?
You can share your.
Okay. Yes, sir. Visible, sir?
Thank you, ma'am. Now are you able to hear my voice?
Yes, sir.
Yeah, thank you very much. Now please
Yes,
project the
sir.
screen. Now we'll start. Sorry for the inconvenience. What happened? Means there is no power till now at my home. 2 hours back, power gone. Just now it came 10 minutes before. So quickly I started the computer, and then now we are able to do the good. Otherwise, I was worrying how to handle these practical sessions. This is just a speaking session. I can handle with the mobile. Till now, I was on my mobile call. Okay, but to give the practical exposure, we need to work with the desktop or laptop. That's why I was asking you also to join through your laptop or desktop. Very good afternoon. Thank you for joining this session to understand the concepts of digital system design using Xilinx Vivado. Madam, is my voice is clear?
Yes, sir.
Yeah. Please put the full screen of this. Yeah. Initially, I will tell you how our 3 days training will go on. Today we will see some basic constructs of Verilog HDL, basics of Verilog HDL, simply I can say. And then we will start with the basic programming. And I will introduce you the tool, that is Xilinx Vivado tool, to you to work on. And tomorrow we will design combination circuits by using Vivado. And the day after tomorrow we will design the sequential circuits and also finite state machines. We will see 1 or 2 programs on finite state machines. Now I hope everybody got the day one lab material. Means I have shared through the Google Classroom. If possible, just now go through your Google Class, and then see the material whatever I have shared with you, and you have to download that material and keep it ready for the practical session. Before practical session starts, I would like to give you the basic knowledge. Basics of Verilog HDL.
Say, is the
Madam,
screen clear?
yeah, your screen is clear. I hope I can project my screen only. Okay. Madam, will you give me permission to share my screen?
Yes, sir. Yes, sir. I'll start. You can present it, sir.
Sir, able to see my screen?
No, sir.
Now?
Yes, sir. Yes, sir.
Anyone please unmute yourself and then tell me. Means whether you are able to see my screen or not.
No, sir.
Yeah, thank you. Now, before starting the lab hands-on session, now let us go through the basic concepts of Verilog HDL, which is required to understand. Why? Because as per your ma'am, I mean, I am speaking about the students part. Students are having the Verilog HDL as part of the curriculum, and they wanted to complete their lab sessions, okay, without going to the class, and during this pandemic. That's why it means we have arranged this session. So whatever I will project here, that will help you to complete all the Verilog HDL programming at your home itself, and get ready for the final exams. Anyway, that is the main actual motto. But apart from that, I would like to give you some of the concepts which will help you to enhance your programming skills. Why? Because as the electronics engineer, and you should have your core knowledge, and there are good jobs in VLSI, that too especially in the front end design. Especially in front end design indicates that writing the HDL programming and then verifying the code. Please, all of you be in mute mode. Some of you are in unmute mode, so that disturb the class a lot. Now, just have the basic concepts. So first, we will see what is the integrated circuit design flow, what we follow. Now, this is the digital integrated circuit flow, or we can say simply VLSI design flow, which can be used for designing digital integrated circuits using field programmable gate arrays and also ASIC. That means in my previous webinar, I given you the concept of a full custom design, semi-custom design, and field programmable gate arrays design. Now, this is the flow. What I am projecting here will help us to go through the semi-custom and field programmable gate array. It is not for the full custom. Full custom means there is need of starting from the transistor level, but in FPGA flow as well, ASIC, application specific integrated design flow, we will not use that. Okay, now here whatever I projected, this is a semi custom VLSI design flow used for designing in digital integrated circuits. Now first step is market requirement. Actually here we need to capture the market requirements. What are the market requirements? See, if you would like to design a digital system, a digital integrated circuit for a real-time application, first of all you have to see the specifications of that one. Specifications: number of inputs, number of outputs, performance, functionality, and physical structure. These all are the requirements. If you take the mobile phone is a market requirement. Okay, mobile phone should have what are the features, what is the functionality, and what kind of input facilities should be there, what kind of output facilities should be there. These all are the market requirements. And if you come to the your basics level, that is, let us take the half adder. If you look at the half adder, there how many inputs are required, how many outputs are required, and what is the functionality. If inputs are 0 0, what is the output? 0 1, what is the output? 1 0, what is the output? This all comes under the requirements and specifications. Now that requirements and specifications either from the market or from the customer. Okay, we can get these informations either from the market. If you want to develop a product by your own, to release into the market, you can see the market requirements. Or if some customer approached you and asked you to develop an integrated circuit for his application, then you have to look at the specifications, what that customer is expecting for his design. So that is what in the market requirements, what we do is we can capture the specifications or requirement in the form of functionality, inputs, outputs, and physical structure. Okay, these are all what we expect. After that, we can conceptualize whatever we have captured during the first step, that is market requirement stage. Then we can go for designing the architecture. That means we can conceptualize the concepts, whatever we capture, we can put them in the form of architecture. In the form of architecture, in the case that an architecture will have again the number of inputs and what are the names of inputs, number of output, what are the names of the outputs, and how many functional units is required. This all comes under the architectural design. Now if you look at the again example of the half adder, market requirements is design of the half adder with 2 inputs, 2 outputs, and that should satisfy the truth table. Now in the architecture design, what we do, we can clearly mention, okay, what is the name of the input, what is the name of the output, what is the name of the module, okay, what finally we are giving name to that particular integrated circuit, and how you are going to represent the internal behavior. Now in the market requirements or specification capture stage, we have taken just the behavior, but how to keep that behavior, that also we can conceptualize in architecture design stage. After that, we enter into next stage, that is the logic design stage. In the logic design stage, we can develop the logic. We can develop the logic for the system requirements based on the architecture how we have developed. Now here let us take again the example of half adder. Now half adder truth table, you know. Now here designing the logic is how to implement the truth table is the development of the logic. That is what logic design. Here in this logic design, what you do, you can keep the behavior of the design in the form of Boolean equation or algorithm. Now that is what we are going to do during the logic design. We can conceptualize the requirements and architecture what we have developed into a form Boolean equation or algorithm. After that, we go for HDL coding. Here HDL states that hardware description language, and that is what we are going to use Verilog HDL. There are various kinds of HDLs, but in this training program, we will be concentrating more on Verilog HDL. Okay. After developing the logic, then we write the Verilog
HDL code. That is what HDL coding. At times we can call that HDL code as RTL code. RTL code or RTL description. Here RTL states that register transfer level. Register transfer level. Now after writing the RTL or HDL code, we need to verify the functionality. That is what the RTL verification. That is what RTL verification, where we can simulate the HDL code and then verify the whether the specifications or market requirement what we captured at the first stage are met or not. If the specifications are met, then that enter into the next stage where we do synthesis, DFT and static timing analysis. After that it goes on to the implementation. If specifications are not met, then we need to rework on the HDL coding. That is what. If specifications are met, yes, go to the next step. No, go back to the HDL coding and you have to refine the HDL coding to meet the specifications. Now in this training, we will be concentrating more on this. Why? Because you have to understand how to capture the market requirements, how to conceptualize them as the architecture, and how to develop the logic for the design, and then how do we use the Verilog constructs to design the system, and then how to verify the behavior of the HDL code what we have written. Now this is what we do in the first phase, and during this 3 days training also you will be concentrating more on these concepts, capturing the requirements, then developing the architecture, develop the logic, do HDL coding, and then verify through the simulation process. After the successful verification of the HDL code, then synthesis, we enter into the next phase. Here this complete VLSI design is explained in 3 phases. Now first phase is writing the HDL programming and then verifying the code. After successful verification of the code, that goes to the next phase or next level, where we convert HDL language into the gate level netlist. If you want to implement that on the FEG, or if you want to manufacture, then the HDL code is having only English letters. That English letters are not enough. There is need of converting that English letters into a structure, that is gate level structure, and that will be done by the synthesis process. Here synthesis, what that do, that converts your HDL code into the gate level netlist, that to optimize the gate level netlist. During the synthesis process, a tool, whatever tool we will be using here, that tool will work on optimization also. That means whatever English letters you have written in the HDL coding, that need to be converted into the minimum number of logic gates. That is what optimization. Optimization indicates that usage of less number of gates to implement the logic. Now during the synthesis process, the HDL code, whatever we have written, that will be converted into the gate level netlist. After converting into the gate level netlist, we can understand the concept of DFT. Here DFT is designed for testability. I hope you know what is design for testability. Yes, during the simulation we have verified the functional behavior, but after converting the HDL into the gate level netlist, then we have the gate level netlist. Then we can apply the DFT concept, design for testability concept, to that gate level netlist, and then we can find any faults occurred during the synthesis process or not. If any faults are occurred, then we can rework on that. After checking the equivalence, here equivalence means at the time of HDL coding one simulation was done. After during the DFT one more verification will be done, and both are matched and all the gates are properly aligned, then we can say equivalent check is done successfully, and then we verify the timing analysis. That is what STA states, that static timing analysis. After verifying the gate level netlist functionality, again we see whether that is meeting the timing requirement or not. During the static analysis, we can apply some timing procedures. After that, we can see whether this design system is meeting the requirements or not. If that is not meeting the requirements, and then we go back to the synthesis process. during the synthesis, we have to go set the optimization level. Based on the optimization level, this timing requirements will vary. If that is meeting the timing requirements, what we have captured during the market requirement stage, then that design is good to go to the next level, where we can verify the physical feasibility of the design. That can be done by placing the gate level netlist onto the floor of field programmable gate array, and then place, route, placement, and then routing, placing all the gates, and then giving the interconnection between the gates, that is what, place and route. And then again verify the static timing analysis. And finally, after completion of this place route, we could see the physical structure of the hardware, the design system. And then we can see the physical verification. That means whether that is physically feasible to manufacture or not. There are some checkpoints. Here also we can use the tool. Okay, if the checkpoints are met, and then sent for the tape out. Tape out means where manufacturing will happen. Where manufacturing will happen for the ASIC, application specific integrated circuit. But for the FPGAs, we can convert the physical verification file into the bit file and then download onto the FPGA. Now after this, the diverse, okay, whether to tape out, that is foundry to manufacture the IC, or send downloading onto the FPGA to verify the physical correctness. Okay, then if it went to the tape out, then manufacturing will happen. Finally, manufactured IC will be the output of this design flow. Now I hope you understood what the VLSI design flow we follow to manufacture the integrated circuits or to implement the design on FPGA. Now here, whatever this design flow is projected, this is for semi-custom, not custom design. Here all this flow will work with gate level netlist only. That's why directly we converted the HDL code into the gate level netlist. Now any query regarding this? If you have any query, I will take it up. I hope. But in training, we'll be concentrating more on this part. And then this part. Now this part will not in our hand. Actually, automatically Xilinx Vivado tool will map everything, and that will give the output. Okay, this third level we cannot do anything, and the automatical tool will do. And here during the synthesis, this also automatical tool only will do, but there is some things in our hand we can do. Okay, that I tell you while working on the tool for the synthesis. Then this one is completely in our hand. We only have to do market requirements, and we only have to design the architecture for the specifications captured during the market requirement stage, and then we only have to develop the logic for the behavior of the design, and then we only have to write the program, and then we have to verify by writing the test bench. Now our more concentration will be on first level. Second level partially we do, remaining will be done by the tool automatically. Of third level is completely tool will do. Any queries here? If you have any queries, I will take it up at present. Otherwise, we will go to the next. Now, before going to explain you the Verilog HDL and the process what we follow for implementing the VLSI circuits on FPGAs, I want to tell you what is the design flow what we need to follow generally in VLSI. Any query here? If you don't have any query, we'll go next. Please, anyone unmute yourself, then tell me. Good to go next, or have the queries? Are you with me? Are you able to hear my voice?
Sir, okay, sir. Proceed, sir.
Yes?
Proceed further, sir. Hello.
But no response from the audience. That's what I'm worrying. Whether they are able to hear me. Any participant?
Anyone, any student?
Yes, sir, audible.
You have the control. It is audible. Any queries here?
No. Yes, like audible. Sir, want to proceed further or have any doubts? Sir is asking. Anyone?
What is GLS, sir? Hello, sir.
Hello.
Hello, sir. What is GLS?
1 minute. Here, static timing analysis and GLS, that is the gate level simulation.
Okay, sir.
Actually, after routing, see here, there are three kinds of simulations. At the first level, we simulate to know the behavior of the HDL. At the second level, again, we do simulation to verify the behavior after converting into the gate level netlist. At the third level, again, we do the simulation after placing the gates, all the logic gates onto the floor plan and placing them and then routing after giving the connections. Again, we need to verify whether the functionality is correct or not. That is what. Again, we verify STA and GLS. Both we will do
Okay, sir. Thank you.
at that stage. But actually, this will be done by our tool automatically during the FPGA process. We have the control means at level 1 and level 2. Any more query? Now let us look at next. Now I already explained this, the system design abstraction levels in my previous webinar also with 2 diagrams. But here again, just I am giving you the knowledge on which we are working during this training program. Now you could see this is 5 levels of abstraction. Now system level, functional or module level, can gate level, circuit level, and device level. During the device level, we can interconnect the transistors to develop the, sorry, at the device level, we can interconnect the layers to develop the devices. The circuit level, we can interconnect the transistors to develop the gates, right? At the gate level, we interconnect the logic gates to develop the modules. Modules is subsystems of a bigger system. Then during the module level, we interconnect and then we can develop complete system. Okay, this is what the flow we can use for full custom design. But here we are starting from the HDL programming. So we will not work with circuit level and device level. We will be starting from the gate. That means HDL code can be converted to the gate level and during the synthesis process. After this, interconnecting the logic gates as a subsystem, that is module level, and then system. Now these processes we can understand. Level 2, level 3, and level 3, level 4, level 5. These 3 we will be working on during this training program, starting from the gate to module, module to system. Okay. Anyway, you will get the hands-on practice of how to interconnect the logic gates to make it as module and how to interconnect the modules to make it as the bigger system. Okay, that will come in third day. Now already I shown you this also in my previous class, differences between ASICs and FPGAs. Now here just see the overview. Here ASICs are low, but FPGA is high unit cost, but there is too much amount is required for manufacturing the ASIC. Okay, manufacturing of 1 lakh ICs is low cost, but manufacturing single IC cost too high as compared to the FPGA. And main parameters, they look at the first 4 parameters. The first 4 parameters of the FPGA, that is functionality is programmable, that means flexible, time to market is fast, NRE, non-engineering cost, and non-recurring engineering cost, that is also low, and design flow also simple. Now these are the 4 parameters which make the FPGA different from the ASIC and also suits the current requirements. Why? Because current requirements are time to market should be very fast. Okay, that is what current requirement. So people are going for FPGAs to satisfy this time to market with the low NRE cost. and it has the programmable. Why? Because if you want to upgrade the product, immediately that is possible. But in the IC, if you want to upgrade the product, you have to again manufacture the new IC. Here it is not like that. Just reprogram the architecture of the FPGA. That itself gives you the new design. Okay, that is FPGA having the advantages. Now with this, let us go to the next. I hope no need to explain the much. This also I explained you in last class itself. Now this also is in my webinar. I given you the information about this. Now let us look at this. This is what the flow, what we are following during this 3 days training program. First, we captured the specifications. That is what market requirements in the VLS design flow. But this is the FPGA design flow. In short, I'm explaining you here. Okay, function specifications we do, and then we write the HDL program. Between these two, there is 2 steps. We need to develop the architecture, and then we need to develop the logic. After developing the logic, we can go for HDL, hardware description language, code for the functional specifications, and then we verify the behavior, that is behavioral simulation after HDL1, and then we do synthesis, then place and route. Again, static timing analysis and simulation. Here that GLS also will falls here. And then after this, we bit file will be converted, and that bit file will be downloaded onto the FPGA to verify the circuit. Okay, and here we can do this total process by using the Xilinx Vivado, and these Vivados are Xilinx Vivado tool is a GUI, that is a graphical user interface driven, and also support the scripting languages. And here we use this Vivado and FPGAs. At MLRIT we have Nexus 4 and Jet boards, and these all are cheaper only. You also can ask your management to purchase. Why? Because these devices cost around 20 to 25,000 each device. If you have purchased at 5 to 10 devices for the department, that would be better. That is my suggestion, but up to your management and you people request. But here I cannot show you the practical experience on the FPGA devices. But after this pandemic, if possible, you can invite me, and I can explain you at your place if you have the boards. Otherwise, I invite you one day. Okay, if everything is fine, and you can come down to my college, and then I will show you the process in one day. There you can get the practical experience. But here, during this training program, I will give you the experience of this Xilinx Vivado tool. These are the 4 hardware description languages: VHDL, Verilog, HDL, and System C. VHDL, Verilog, HDL, and System Verilog. System Verilog and System C. These are the 4 hardware description languages we use. But during your engineering, you will be understanding only VHDL and Verilog. And the System C and System Verilog both are high-level hardware description languages used for functional verification of the complex systems. That is why they support the software and embedded programming and object-oriented programming also, System C and System Verilog. But if you look at the VHDL, Verilog, these all supports only behavioral and RTL, structural and switch level. These 2 languages cannot support the object-oriented programming and also software and embedded programming. But nowadays, these companies are embedding some of the features into the VHDL and Verilog so that this also satisfies the requirements of the industry. But as of now, I can say strictly we can use the Verilog for behavioral description, RTL description, and the structural description, and the switch level description. Okay, that is what modeling. And we use these 4 kinds of coding styles. That is behavioral coding style, RTL coding style, and structural coding style, and the switch level coding style. Modeling indicates the type of style we follow for the coding. Okay, these are the 4 coding styles what we use in Verilog HDL. The same will be supported by VHDL, but VHDL cannot support the switch level. Okay, so VHDL will support only RTL, structural, and behavioral. Now with this, we will move to the next concept of Verilog HDL, where we can understand the core of Verilog HDL. From here, I can conclude that out of these hardware description languages, we will be using Verilog HDL. Okay, is it good to go next? Anyone, please unmute yourself and then let me know. Are you understanding? Are you
Yes, sir.
moving?
Yes, sir.
Thank you. Now we have seen these Verilog design flow and abstraction levels also we have seen, and the difference between ASICs and FEG architectures already in my webinar I explained you. And just now we have seen how designs are implemented on FEG. That is what FEG design flow. Now bear with me, means you have to understand the theory concepts before starting the lab session. That's why I'm spending a little time here. It will not take much time, another half an hour. I will give you theory and then we will enter into the practical sessions. Now these are the objectives what we can see now. That is how basic module of Verilog HDL looks like, and then differences between simulation and functional verification, then synthesis process and the concurrency, and finally I can show you some system tasks. But the system tasks are not required, but it is good to know what are the system tasks we have here in Verilog HDL. Now, as I said, there are two HDL standards developed, that is VHDL and Verilog. VHDL is a very high-speed integrated circuit hardware description language, called it as VHSIC HDL, where V indicates VHDL. In the VHDL, V indicates VHSIC, very high-speed integrated circuit HDL. Here, Verilog HDL is verification of logic hardware description language, and which was developed by the Cadence data systems. Later on, that became the standard under the organization Open Verilog International. Now, this Verilog HDL, all the constructs were maintained by Open Verilog International. Now, let us look into the Verilog in depth. It was developed by the Gateway Design Automation. Actually, originally, this Verilog HDL was developed by Gateway Design Automation in 1984. Okay, then acquired by Cadence company. That's why, means in previous slide I said this Verilog was introduced by the Cadence company. But developed by this Gateway Design Automation. Later on, that is merged with Cadence company. Now, in the 1990, they made it as open standard. Okay. Verilog HDL became open standard in 1990 under the control of Open Verilog International. After that, it has become the IEEE standard in 1995. 1995 onwards, they have given the official one standard, that is IEEE. All the programming languages and circuits, electronic circuits, whatever we use, everything should undergo the standards check. After checking the standards, that IEEE will give the some number, reference number, and they use that reference number for claiming the standard. Okay, and it was updated in 2001 and 2005. 1995 it became the IEEE standard, and then 2001 one kind of updation was happened. Now 2005 another updation was happened, and in the 2009 some of the features of Verilog HDL is merged with the system Verilog and made the standard of IEEE 1800 2009. Okay. Now this Verilog HDL is used for simulation and as well synthesizable. So it is having the constructs which supports the simulation and synthesize. Okay, this Verilog HDL can be used for describing the hardware systems, that is digital systems, and also synthesize. After that, this HDL cannot do anything else. The rest everything will be done by the scripting languages and also automation tools, automation EDA tools. Okay. Now this is the introduction to the Verilog HDL. Now let us look into the Verilog basic structure. Now at the right hand side you can see. Are you able to see my screen? Anyone unmute yourself?
Yes, sir.
Please let
Yes,
me
sir.
know.
Yes, sir. I can see.
Yeah. Thank you. Now here right hand side you could see the module module name, then port list are kept in the bracket, and then whatever port list kept in the bracket, they became the interfaces. To define the interfaces, we need to declare them as the ports, and parameters also we declare here. And then if there are add-ons required, add-ons means in the C language you might have seen the header files, right? Now at this point of time, I wanted to know something from you. Now, is there anybody who can explain me the construct of C language structure? How that C language starts? That also having the one programming structure. Am I right? Now I am explaining the programming structure of the Verilog HDL. Now, before going to explain this programming structure of Verilog HDL, I would like to know the programming structure of the C language from any of you.
Sir, header files, main, void main, and the end, some functions. That's all, sir.
Yes.
Is it so, sir?
Great, ma'am.
Yes.
Yeah. Thank
okay,
you.
sir. Okay, sir.
Yeah. Now, as your friend said, C language will have the header files, and then main function, and then functions, sub functions, which will be called by the main function. Am I right? Now this main function will be the function which can control all the sub functions, and to support the main function constructs there are header files. Same here also, there will be some header files. Okay, if you have some header files, you can use this. Otherwise, if you want to design the bigger system where you wanted to involve the smaller systems, and you can use those smaller systems as the header files here. Anyway, I will explain you the concepts during the practice sessions. But as of now, you can understand. Okay, what is the add-ons? Okay, this is not compulsory, but it is good to have some files required. Okay, if that is not required, well and good. No need of putting any header file. But port declaration is required. Why? Because these port declarations acts as the interfaces of the system, and here we are describing the hardware system. We are not describing the software system. Okay. After that, body. In the body of the module, we will be explaining all the behaviors of the system. And before explaining the behavior, we can declare the variables which are required for the support and assignments. Then lower level module installations. It's not installation, instantiation. Then always blocks for sequential circuits. Initial and always blocks are sequential constructs. Then functions, tasks or functions if any is required. Now in the body of the module, I can say simply we can describe the behavior of the digital system. To support the behavior of the digital system, these are few of these things are required. If that requires some variables, we can define some variables. If that requires some predefined assignments, we do some predefined assignments, and then we put the logic in the form of the instantiation. Instantiation this indicates that interconnection of the gates. Instantiation indicates that interconnection of the logics. And always block. If there are constructs which need to be executed sequentially, then we can use either initial or always block. Anyway, you can understand all these constructs clearly in the future. But as of now, you can understand that this is the structure of the Verilog, where it starts with the keyword module and end with the keyword end module. Now these are the keywords, module and module. In between, we will have the name for the module, and then port list, and these ports acts as the interface, and then some directives, that is add-ons, and then behavior of the system as the body of the module. Okay, now this is the structure what we do follow for the Verilog. It is very simple structure. Now look at some of the points what we need to remember while doing the Verilog programming. Now as I said, Verilog program starts with a module, like C language always starts with the function main. Am I right? Same here also, main. In the C language, there is a flower bracket, open flower bracket, close flower bracket after the main. Same here, okay. And module. Module keyword itself is the starting of the module, and end module is closing of the module. In between, we can write all the interfaces, the behavior of the system, everything here. Okay. Next, that is what interfaces will have the port and parameter declaration, and body will have the internal part or behavior of the module that will put, and add-ons are optionals. Now look at this, all the constructs, that means all the keywords, whatever we write in HDL, those all are case sensitive. Case sensitive means if you follow the combination of capital and small, and you need to follow the same combination. That means if I say one port name or variable name you are giving, V is capital, A is small, R is small. So you have to follow the same terminology throughout. V capital, A small, R small, VAR. Or if you have written all small, VAR, all small, and you have to follow the same. That is what the case sensitive. I hope you know what is case sensitive. You might have seen this terminology in other programming languages also. Next, all the keywords are lower cases. All the keywords are lower cases. And here white space is used for the readability. White space. Look at this module. After the module, there is white space is given. That indicates that there is the gap between the keyword module and the name of the module. Now here white space is there. This white space is kept here for readability. There is no significance of white space in the Verilog HDL. But if you keep the white space inside the string, I hope you know, you already studied the strings. Inside the string, if you keep this white space, then that can be taken as the character. But here, during the defining Verilog constructs, white space is not having any meaning. That is just for readability. Semicolon can be used for statement terminator. You look at this. Here there is semicolon is kept. It terminates this particular line. Similarly, whatever you write here, every line or statement should be terminated by the semicolon. Okay. Now that also you need to remember. If you forget the semicolon, again this throws the messages saying that will not let you know this is missed. Okay, that says that error at this place. So you have to be careful while writing the program. Next, comments. Like C language. C language also having the possibility of putting the comments. What is the need of the comments? Somebody please unmute yourself and then tell me why we use the comments in the programming languages. In C language, you might have used the comment. Are you understanding what I am asking? Anyone, please unmute yourself and then let me know.
Readability of the program.
Readability of the program. Okay. Any other? I need at least 3 responses.
To know the program execution.
To know the program execution. Okay. Yes.
Use the description
Yes,
about
yes.
the instruction.
Most of the cases we can use the comments to give the description about the constructs. If I have written one construct or one statement, if I want to convey that information why I have written that construct, then I can put some comment there. I can explain, okay, this is the port declaration, or okay, this port is used for interfacing with this. Like that we can put the comments. Here there are 2 kinds of comments constructions are there. That is, one is forward double slash. That can be used for single line comment. That means if you want to comment the single line, just we put the double slash. After that, whatever we write, that can be considered as the comment. If you want to put the multiple lines under the comments, then we can use slash asterisk. In between the 2 slash asterisks, we can put the list of lines. Okay, here it can be for multiple lines. Okay, this is designed for the multiple lines. Okay, which can act as the again comment block. Okay, to put the multiple lines under the comment. Now these are the 2 we can use. One is for a single line comment, another for block comment. Now hereafter means we have started the Verilog concept. That's why I'm asking you to be attentive. Okay, now this is the basic structure of Verilog program. Like in C program, main is the basic structure. Okay, same here also we write all the behaviors of the systems in the format of module. That's why I'm explaining you the module structure. Now this module will have the interfaces, add-ons, and body. And these all are enclosed with the keyword module and end module. Okay, that is what the module structure. Now, if you have any queries, please ask me here. Now, did you understand? Now, let us look at the example. Now, this is the example I kept for the half adder. Now, here let us see how to declare the ports. Now, at the left hand side, see, this is the structure what I explained, but here I explained in the form of the diagram, but now here I can in the statements. Module is the keyword, then module name we need to write, then port list of the input and output ports we need to list out it here, and then first we declare the ports. Here in this text I kept the interface, but what kind of interfaces? Now we need to do port declarations and variables, that is data types. Data type declarations we need to do, then functionality of the system or circuit, and then if there are timing specifications is required, we can put the timing specification. These are the must. Okay, port declaration is must, data type declarations are must. Okay, and then circuit functionality and timing, if timing specifications need to be kept, it is required, otherwise this is optional little. Okay, now if you want to declare the ports, we can follow this. Look at this. Now input, output, in out. There are three kinds of ports you could see in any system: input port, or output port, or input output. That is bidirectional port. That is bidirectional port. Now this is the format what we follow to define the ports. Now port declarations. Look at this port declaration. Port type and port name. So what type of port? That depends on this one. Now if you look at the half adder is having 2 input ports, 2 output ports. Am I right? I hope everybody knows the half adder. That's why I have taken the basic structure to explain the module half adder. That is, input is A, B, output is sum and carry. Now look at this port type. Input port for A and B. For sum and carry, port type is output. If there are in-out, somebody can you tell me where you could see the in-out ports in the digital logic design? You might have studied the DLD. Am I right? In what concept you found the in-out port?
It can be access input as well as an output.
That only means what my question is. In which concept you studied this? That means adders, or combination circuits, or flip-flops, or registers. In which concept you have gone through this bidirectional port?
Generally in sequential circuits, while designing a counter, I need to make the count value like that. That is an example.
Okay, good. Now if you look at the flip-flops, now flip-flops are having the outputs. Those outputs are in-outs. If you look at output is connected as input. Avuna? Now in some of the cases, if you look at the SR flip-flop, Q is given as input to circuit. That means output ports which you could see in the flip-flops are in-out ports. That means that input acts as input. Sorry, that port acts as input as well output. That is bidirectional. If you want to define such type of ports, we can use in-out, where that can act as the bidirectional. But in the half adder, we could see only input ports and output ports. Now look at this, the module, the name of the modules. Next is name of the module. Here name of the module is half adder I given, and this is user defined name. Okay, I hope you need to follow some rules while writing the user defined. We can call this as the identifiers. While formulating the identifiers, we need to follow the rules, and the same rules what you follow in the C language to define the identifiers. Here also we follow the same rules. Can somebody explain me what are the rules you have followed in the C language to formulate the identifiers or variable names? Here identifiers can be treated as variable names. Okay. Now here half adder also module name, that is variable name or some identifier. It's not exactly variable name, that is identifier. Half adder. Now what kind of rules we need to follow here for writing the names? Anyone in the C language have you remembered the rules what we follow for the identifiers? Why I am asking you? I struggled during my MTech. I struggled for around 2 to 3 months because of I formulated the wrong identifier. Because of that, I am getting the errors. I was unable to solve, and I am approaching my friends. They are also unable to solve. I approached my teachers. They are also unable to. And finally, one day, I got to know that I made the wrong during the formation of the identifiers. Now here we need to follow some rules to form the identifiers. Those rules are, that means whenever you give the variable name or port name or module name, whatever names you are putting in the Verilog and C language, we have to use only alphanumeric characters and underscore. Alphanumeric and underscore. Alphanumerics are capital A to Z, small a to Z, and 0 to 9. Additional to this alphanumeric, underscore can be allowed. That is first rule. Second rule is identifier name should not start with number. Identifier name should not start with the number. That was the mistake I done. While writing the program for the multiplexer, I have written, okay, module, multiplexer name is 2, 1 multiplexer. 2 is the starting. Okay, letter, and instead of the letter I kept the number. So that was the error, continuously throwing. Finally, after 2 months, I found that that is the error. That's why I'm telling you. While formulating the names, we need to follow these rules. First rule is alphanumeric and underscore. Second one is that identifier should not start with number and underscore. Identifier name should not start with the number and underscore. These are the 2 rules what we need to remember. Okay. Next is input. Now after this, port declaration. Here ports are inputs and outputs. Under the inputs, A comma B. You can find 2. A comma B are the inputs. Outputs are sum and carry. Sum and carry are the outputs. Now here we have used the comma to differentiate 2 port names. You can put the multiple port names under the same input. If the both are having the same size, if both are having the different size, then we need to take 2 inputs. Okay, one input for one kind of definition, another input keyword for another definition. Later I will explain you. Okay, such type of concepts will come during the discussion. At that time I will explain you. Then output is sum and carry, and then assign. Here assign also a keyword. Assign sum equal to A cap B. In VHDL we can write A XOR B like that, but here there are operators. Later I will explain what are the operators we can use in Verilog HDL. For this understanding purpose, I am giving you the program where cap indicates the XOR and this symbol indicates the AND operation. Now since sum is having the Boolean equation of A XOR B, that's why we have formed this. Okay, this indicates equal to A XOR B. Now assign is the assignment construct, that is Verilog construct, Verilog keyword, what we need to use to assign the right hand side statement to the left hand side statement. In C language, simply if you write sum equal to A cap B, that is fine, but here we need to use the assign construct. Okay, assign construct is the construct used for assigning the equation at the right hand side to the variable at the left hand side. Now here I have used the comment. See here, double slash indicates the comment, as I explained to you previously. Okay, here I am giving the information that this particular equation performs the bitwise OR operation. Like this, we give information. We use the comments for giving the information about this. See, you might be knowing about the cap, but some of you may not know what is the meaning of the cap. So for them, I am giving the information here. This cap performs the bitwise XOR operation. Similarly, here AND performs the bitwise AND operation, logical AND operation, logical OR operation. Then AND module stops the half adder. Now that is comments. Now here you might have seen the semicolons. After every statement there is semicolon. Okay, that we need to follow to terminate that particular statement. Now this is the basic construct of Verilog HDL. Now I hope you understood what is the module declaration of Verilog HDL and how to define the ports. In the future, I will explain you one concept, and then I will give you the example to each one, and you can implement that by using the tool. Now, is it good to go next? All of you understood the concept of what is module and how modules are written. Modules means how program is written. Here now you have understood the concept of basic programming in Verilog. Basic programming of Verilog starts with the module keyword and then module name, port list, then port declaration, and the circuit functionality. Here we have kept the circuit functionality in the form of Boolean equation. Now this is the Boolean equation. Am I right? Sum equal to AX or B is the Boolean equation. Carry is Boolean. That means we have described the behavior of half adder using the Boolean equation. That is how we have made the circuit functionality. And then we closed the AND module. Is it clear?
Yes, sir.
If you have any query related to this, ask me now. Queries? Good to go? Say, give me 3 responses, 3 members at least.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Yes,
you.
sir.
Just I am want to know whether you all are hearing me or switched on the computer and then went off somewhere. Thank you. Now let us understand the simulation. What is simulation functionality? Now you have understood the concept of the module and how to write the code. After writing the code, there is 2 steps need to be done. One is verifying the behavior of the code what we have written, and then converting code to gate level netlist. Now let us understand those 2 concepts, and then we go for working with the tool. Okay. Now logic simulation and function verification. Now this RTL code indicates the HDL code. Here don't get confused. Here we can use 2 terminologies to describe the code. One is RTL, register transfer level is RTL. Okay. Second one is HDL, hardware description language code. RTL code and HDL code both are same. Don't get confused. Now after writing the code, we can verify that using the simulator. Simulator is nothing but that interpret the HDL code. Whatever HDL code you have written, that can be interpreted, okay, by using the simulator, and that simulator takes the input, right, and then produces the output. And during the functional verification, we can verify whether the output is equal to the expected output or not. How do you know expected output? At the first level, that is capturing the specifications, we might have captured the specifications. These are the inputs, these are the outputs. If inputs are this, output should be this. Like that, you might have captured the specifications. After capturing the specifications, we have implemented that by using the RTL code. After RTL code, we have done the simulation. From the simulation, will be some outputs. Now we compare that output with the specifications what we captured. If both are matching, then functional verification is done. The simulation results may not give you pass the functional verification. Functional verification should be passed only when your simulated results are matching with the expected results. That is what the functional verification states, that verification of simulated results with the expected results. That is what functional verification. And simulation means imitating the HDL code virtually. Okay, that is what the interpreter, we can call that as interpreter. Interpreters are always mimic the RTL codes. Okay, now simulator produces the output based on the inputs what we given, and for functional verification verifies the outputs achieved after the simulation with the specifications what we have captured. Okay, that is what functional verification is defined as the process of verifying that RTL design meets its specification from the functional perspective after the simulation testing. Okay, after the functional verification we go to the next logic synthesis, where the RTL code is written and verified is converted into the gate level netlist. Converted into the gate level netlist. Now let us look at that point. Now look at the synthesis. What happens during the synthesis? As I said, logic synthesis is the process of translating and mapping RTL code. RTL code in the sense HDL code what we have written. Okay, into technology specific gate level representation. That means that converts the HDL code. Look at this diagram. That is the HDL code what we have written. That is in the English letters. Okay, all HDL programmings are in English letters. That will be converted into the gate level netlist. The output of synthesis is interconnection of the gates. That is what gate level netlist indicates, that logic gates interconnection as per the program whatever we have done. Now that will be done during the synthesis process. But while doing the synthesis process, it will do 3 operations. First one is translation. That means RTL code is translated into the Boolean equation. RTL code is translated into Boolean equation. And first level, we can call that level as translation. Translation of RTL code into Boolean equation. After translation into the Boolean equation, there is a need of applying the optimization techniques. That level is optimization. Here, Boolean equation is optimized using SOP. SOP indicates sum of product. POS indicates product of sum. And they have the optimization techniques. You might have studied the postulates or theorems, Boolean theorems. Have you studied Boolean theorems? To minimize the Boolean equations. And also K-map methods. K-map methods are again developed by using SOP and POC optimization methods only. K-map is nothing but diagrammatical representation of SOP and POS optimization techniques only. Okay, that means apply the SOP and POS optimization techniques and then optimize the Boolean equation. I hope you understood the process of optimization during your STLD or DLD subject. There they might have asked you to minimize the Boolean equation to the minimum number of literals. Am I right? Now that will be applied during the synthesis optimization step. After that, mapping will happen. During the mapping, the technology libraries are there, and those technology libraries are mapped with the codes and then generate the gate level netlist. That is what technology independent Boolean logic equation, that is output of the optimization method, are mapped to the technology dependent library. See, before this, the Boolean equation is technology independent. Now that will be mapped with the technology dependent library logic gates and produces the optimized gate level netlist. That is what the gate level netlist we could see here. Now that is the logic synthesis process. Here simply synthesis converts the Verilog code into the gate level netlist. While doing that, you do this process. Okay. Now after the gate level netlist, again we do verification. That is gate level functional verification. That already I explained enough times in my previous classes also. That is okay. Now I hope, is it good to go next? I hope here you understood what is simulation and what is functional verification, what is the importance of simulation of functional verification. If functional verification fails, then we need to refine the RTL code in order to get the functional verification satisfied. Okay, simulation results are always cannot satisfy the functional verification. Now after that, we convert the HDL code into the gate level netlist. Next, kind of constructs. We have two kinds of constructs: concurrency statements and sequence statements. In future, you will understand what are the concurrency statements, what are the sequence statements. No need to spend much time here. Why? Because we have very less time to work on. Now, programming language interfaces. See here, display. In the C language, you can see printf. What is the purpose of printf? Anyone please unmute yourself and then tell me what is the purpose of printf in C language?
Display the output.
Yeah, to display the output on the screen. Am I right? Same. Also, if you want to display some output on the screen, we can use these PLIs, programming language interfaces and system tasks. No need of spending much time here also, because this is not much useful for you, but this is important to test your logics effectively, but no need to spend much time on this. Now we have seen these concepts. Now I hope this information is enough. We have seen the FPGA design flow. That is what design flow we follow to implement the digital systems on FPGA. And then you have seen the module and how to write the basic program for half adder. Next, you have seen the simulation process and synthesis process. Now, these three concepts are enough to start with the Verilog HDL. If you have any queries related to these concepts, please put the query now itself. I will clear the queries here and then we will move to the tool. How many have installed the tools? Everyone? Here I could see the number 87. All 87 are introduced, sorry, installed there. Already I said bidirectional ports can be used in the flip-flops. Flip-flop outputs all are bidirectional ports. In the future also, means you can come across. The buses, I will let you know the vectors. While doing the programming, I will let you know the vectors. Anish Verma, you can unmute yourself and then ask me question clearly. Here just you kept the register. What is the meaning of that? Are you there?
Sir, I think he is given the
Anish?
answer. Where we use bidirectional ports, he is given the answer for buses
Answer.
registers.
Yes, that is
Okay, okay, good. Okay, thank you. Actually, thank you, Anish.
Thank you, sir.
Now is it good to go? Now I hope everybody understood the basic concepts. Now let us move to work on the tool. Now after installation, you could see. Are you able to see my screen? My system?
No, sir.
Sorry, I might have changed this profile pic. Now double click on this Vivado. Then that will open. Here you can see Vivado 2015 and HLS. Don't use the HLS. I am asking you to double click on Vivado. Double click on Vivado, not HLS. Okay. Now let me know whenever all are open this window, then I will start the practical session. Now all of you go through Google Classroom. In the Google Classroom, I have shared you the information. Okay, what are the programs you have to simulate today? Now in the Google Classroom, this is the Google Classroom. This is the day one material. Okay. Download the day one material. Are able to access the day one material? Now RAR file I have shared. Lab sources. Say yes or no. Then download and save it in one folder. I suggest you to create one folder in one drive. See, D drive suggestible is D drive or E drive. Don't save in the C drive. Open one folder and give the name, whatever name you would like to give, but give the name related to the VHDL, Verilog training program. That means your name underscore Verilog, so that you can remember in the future. And then copy these all files into that folder. And then open this window. All of you having the laptops? Yes? 88 are appearing here. Out of 88, you can take out 3. Me, Aruna ma'am also work with you. And one more Priyadarshini ma'am. Indira Priyadarshini. And the remaining all are students only, and any faculties are there here? Actually, that's why I was asking you to follow the nomenclature so that we can understand who are the students, who are the faculty, and from which college. But unfortunately, in the Google Meet, I hope that option is not there. Am I right? If anybody knows how to change the name, please help the others. So that will help us to identify, recognize you. Here somebody is asking link, please. Google Classroom link. Aruna madam, will you help them? Click on the link and then use the code what Indira Priyadarshini ma'am shared with you. Now if you say yes, you are ready with the window, then I start. Otherwise, if I start also useless. That's why I'm asking you.
Excuse me, sir. Hello, sir. Hello, sir. Excuse me, sir.
Sir, wait for 2 minutes.
Okay, madam.
Sir, someone is calling you, sir.
Me?
Hello, sir.
Yeah?
Sir, you shared
yes.
one file in the Google Classroom.
Yes, yes.
Yeah, that file only 7 KB, sir.
Only?
Only 7 KB, the size of the file.
This one only was speaking?
Yes, sir.
This only was speaking?
Yes, sir. Yes, sir.
This only?
Yes.
Yeah, that will have very less. That is only programs I shared you.
Yeah, but while opening that file, not opening, sir. The corrupting coming.
No, you have to open that with notepad.
Yeah, it's RAR file. Now first we need to unzip now. We need to unRAR.
Yes, you have to. Yes.
I'm unable to.
Now, this is what I shared with you.
Yeah.
lab sources, rar file I have shared,
Yes.
and you can unrar it, okay, extract, and then these are the files you can see. Three tasks you can find, and here I have given you the programs.
Actually, I'm
Direct
unable
programs.
to do rar, sir. Unrar, sir.
And then you have to install the rar software in our computer.
No, sir, I have. No
Any
archives
other
found.
is facing the same problem?
I'm getting no
Is there
archives
anybody
found,
else is
sir. I'm getting message no archives found.
All are facing the same problem? If everybody is facing the same
No,
problem,
sir, it's opening.
this is opening now. I think problem
It's
with
opening,
your
sir.
computer. Please install that WinRAR. So yeah, it is opening. I could see here. Okay. Yeah, again means install. It takes very less time. Installation of RAR. That hardly takes 5 minutes.
Ma.
It's showing class not found.
Which class? Google class. Huh?
Yes, yes.
I was speaking about the Google class.
Yes, sir.
Yeah.
Yeah.
So you have to use this code. Otherwise, all of you, whoever is facing problem with the Google class, I will let you know how to go to the Google class. Here you could see the dots, many dots symbol, total 9 dots you could see. And here, click on that and go to the classroom. Okay. Click on this and then go to classroom. After this, if you are already having the classes, that will show you the classes. Otherwise, you have to click on this plus. Click on the plus and then join the class. Join the class and give the class code. That is very simple. Go to the classes and then at the right top you could see the plus symbol. Click on the plus symbol and then select the option, join, and then give the class code. Still, is there any problem facing? Sagar. How to view the file? Okay. Now this is the class. Now in the class you can see the classwork. Go to the classwork. Under the classwork you can find the files. Everybody is ready with the tool opened on the computer, then I will start. And then I will explain you how to save the file also, that is licensing also. We are using the free license only, that have the limitations. Okay. All the features are not enabled in that free license, but it serves the purpose of our training. Now at the same time I am uploading the license file. All of you download that license file also. Now you have to download two things. One is license file, another one is material, both. Okay. Ayappan. Ayappan. Ayappan Somasundaram. Please mute your audio. Are you ready with the tool? Say yes or no.
Yes, sir.
Yes, sir.
Yes.
Yes,
Please,
sir.
whoever is ready with the tool, just type yes in the chat box quickly, so that if I get enough number of S's, then I can start. And if whoever is facing critical problems, also post here, so immediately I can try to solve them.
Maruti Rao sir, he is not able to join the class.
Join the class is very easy, madam. Actually, means I told the steps. Have you sent them invitation?
Yes, sir. Just joining the class, he is having the problem.
What problem he is facing?
Not able to join the class.
Not able to join, or some code is wrong, like that. Any message you may get.
Maruti Rao. Provide link to software, ma'am. Should we download the license file also?
License file also you can download. I means whoever is not having a license, for them, actually I have seen some messages in the WhatsApp group stating that some of you facing the license problem, so I wanted to give you the license. Whatever license you have downloaded, you can share the same license with your friends also. Why? Because that is the same license for everyone. That is free license only. And now somebody is asking to share the link of software. Ravi Kumar. You have to select system edition while installation, Sagar. Now you people are doing installation. That installation itself takes half an hour to 1 hour. That's why means I was asking you to install it before. Yes. It's 6 GB. If you want to download the current version, it is 25 GB. Now I given you software of 6 GB. That is very less. And if you don't have the Wi-Fi, you can approach Aruna madam and Indra madam. They can give you in pen drive. Yes, Vivado System Medicine, you have to select while installation. Now here Aruna ma'am posted the Google Drive link. All of you note down Google link drive to download the software. Whoever is not having. What error you are getting? License step Sri Lakshmi.
Ravli ma'am.
Sri Lakshmi Ravali.
Ma'am,
What
you
Sir,
error you are
here I am
getting?
getting 3 options. Start now, 30-day trial. When I click it,
I will tell you. Means for all of you at a time, I will tell you how to up the license. Installation is successful. Keep quiet. Means I will tell you. Actually, in my computer also, I need to set up the license, so I can explain you at a time. Okay, don't worry about that. But if software is installed, let me know. We will start the
sir, like,
programming at the time of simulation, ma'am.
I'm getting here, I'm stuck here. So is it installed or not? I'm unable to decide.
Means you are able to see the license for license tab.
I'm getting a file. I mean, the file name is Vivado License Manager 2015.2.
Yeah. That means that is installed successfully. Software is installed successfully.
Okay.
If you are getting that window, indicates that software is installed successfully, and then that is asking you to license.
Okay.
Okay, I will tell you that process.
Okay, sir.
Yes, we will be using evolution version only. Paid version we don't have, and that too, paid version is cost as well. We need to take for the server, but evolution version is enough for us to start the programming. Today we are a bit fortunate. Why? Because power came at 12 o'clock and came at 2 p.m. exactly before starting this session. Otherwise, we would have faced the problem. Destination directly you can choose C drive or D drive. That's enough. Sagar. Okay, now I hope most of the people are ready with the software. I could see very few yeses. Hardly 10 yeses. Yes, I am seeing here. What about remaining? Now installing the software or what?
Sir, the license is not downloading, it is just opening, sir, file.
That is, if you start now downloading, that takes time, sir. Actually,
No, not license
that
file.
takes a minimum. License file immediately that will be generated, downloaded. That does not take much time. That is in terms of kilobytes only.
No, it is opening, sir.
Download and save it.
The downloading link is not
No.
there. Only opening, it is opening.
After opening, save it. Save as. After opening, save it as. I will be showing it. Means like this. If you open it, open in window. And then download it. Save it as. Now like this, it will be downloaded. And the save. File name. Save as. .lic. Save like that only. Otherwise, I will put it in the folder and then I will share you through Google Drive. That is also better. Aruna madam?
Tell me, sir.
Will you place the license file in the folder where you have shared the software?
Yes, sir. Yes, sir.
You have shared the software in the folder, no? You can paste this license file also in the same folder.
Yes, sir.
So that makes the people easy to download now this folder. Okay, let us start. Now this is the window you can see. After installation of the software successfully, and then here you can see Vivado 2000. That means Vivado, not HLS. You have to open the simple Vivado file. Okay, 2015 file, not HLS. Keep that in mind. Then you will get this kind of window. Don't open the HLS. HLS indicates the high level synthesis. Now that is the new version of this Vivado. That is not required now for us. Now after open this, click on the create new file, new project. Sorry. Click on new project or go to file, click on new, select the new, any option, click on new project or go to file, select the new project, whichever is convenient to you, you can do. Both gives you this window. It's done. Arna madam, can you recognize how many are ready? Already means we kept the RAR file in the Google class, that is enough. Okay, if I send you through the mail also same. Okay, create a new Vivado project, then click on next, then that will give you this window. Here you have to give the name for the project. Now would you like to implement the half adder? Give the HA half adder name you can give. Otherwise logic gates, if you want to implement the logic gates, you can give the name of the logic gates. Since we have seen the half adder, okay, let us implement the half adder of underscore adder. This is the user defined name. Okay, that is identifier. We need to follow those rules strictly. These names should not start with number and underscore, and we have to use only alphanumeric and underscores only for the names. Next, here you can select the directory where you want it to save. Means as I told you to select or to create one folder. Here I have created one folder in the academics STP student training program, and under that day 1 day 2 like that I kept. You also create one folder in any drive and then give the name, and that if you want you can put the day 1 day 2 day 3, that is up to you, but try to work with separate folder. Okay, and then divert here, select the path of that folder, whatever folder you have created for working with, that is we can say working folder or working directory. Okay, give the path of that working directly clicking on this. So whatever project you are writing now, that will be saved in that file folder. Now all of you completed up to this. Is it good to go next? Anyone unmute yourself, then tell me yes.
Yes, yes.
Yeah, thank you. Now next, without delay, go to the next. Now here you can see many options. RTL project. Select the RTL project. That means we are writing the HDL program. That is RTL program. That's why I am selecting the RTL project. If you are already having this gate level netlist, then you can select this post synthesis project. Here we have to load the synthesized file, and here after IO planning, input output planning, we can select here the final stage. Okay, all these things. But here RTL project. Select the RTL project. And here you could see the information. You will be able to add sources, create block design in IP integrator, generate IPs, run RTL analysis, synthesis, implementation, design, okay, planning, analysis. Okay, these are all things we can do if you select RTL. That is what they are giving the information. Here we have to start with the sources. Source means you're creating the HDL file. That's why select the RTL project and then click next. Then here you can see the option to add or create. Okay, specify HDL and netlist file or add. Okay, now click on the plus symbol. If you want to add now, already if you have the file, you can choose the add option. Otherwise, choose the create option. As of now, let us assume that you don't have the file. So we need to create the file. So create on file. Click on the create file. If you are facing any problem during the steps, if you are unable to follow, just unmute yourself, ask me immediately. Means while working on this, I cannot see the windows. Otherwise, Aruna madam and Priyadarshini madam, you people please help me. If any queries they post in the messages, please let me know so that I can handle that query immediately.
Yes, sir. Yes, sir.
Sure, sir.
Now after this, give the name. I am giving the name same as the module name. No problem. If you give the name of this as the module name, also no problem. Otherwise, you can give other name. I want to give half adder. HA is the name of the file. Okay. Now whatever name you will be giving here, this name acts as the module name. Now here, whatever module name you find, half adder, okay? And whatever name you are giving here, that acts as module name. Click OK. Don't touch anything here. And here you can see target language. Here you could see 2 languages. Since we are working with Verilog HDL, select Verilog. And here simulation language, you can select the mixed language, or you can select the Verilog also, but I suggest you to select the mixed. Now after completion of this, click on next. Again it will ask you to add the IPs. Here we no need to add the IPs. We are not working with IP. IP indicates here intellectual property. IP is already available, few IPs, and I will not explain that concept. In future, if time permits, we will conduct one more session for the IPs. That again takes 3-4 days time, okay, to deal with the IPs. That's why we are not touching the IPs. Then go to the next. Next, add constraints. I will tell you later how to add the constraints. As of now, pass it. Okay, don't choose anything here. Next. Here, you can choose the boards. Under the board, you can select the JET board. JET board, Zinc Evolution Family board. Otherwise, here you can see the parts. Based on the FPGA device available with you, you have to select, but I'm asking you to select the jet board. Why? Because I have the jet board. So in future you can work with that jet board. So I am asking you to select the jet board. Otherwise you can select any other board also, no, not a problem. But here we need to select the board which is available with us to work. And this is must. Okay, you have to select any one of the board. Otherwise, okay, writing the program and then doing the remaining steps is difficult. Okay, all of you completed up to this. Then next, after next, you could see the project summary. Project name is half adder. On one source file we have created. Source file means .v file we have created, but we need to specify the body of the .v file. That we do next phase. Next, no configurable IP file is selected. No constraints file also selected. And the Zinc, this is the board you have selected, okay, to work with. Now the information related to that Zinc board. That is jet board is having the Zinc family. As I explained you in my webinar, the various families of FPGAs, where last one is the Zinc. That is the heterogeneous platform. Okay. Now after this, click on finish. After this, you will get one window, pop-up window. This is half adder. Since we given half adder is the source file name, so the same source file name acting as the module name, half adder. That is what here, this module name. This is the name of the module. Okay, that is half adder. Now it is asking us to give the inputs. What are the input pins you wanted to select? Since we have decided to implement the half adder, so what are the inputs? Two inputs. A. You want to take capital A, small a. What you would like to take? And if you take the small a, you have to follow the small a throughout. If you take the capital A here, you have to follow the capital A throughout. That is what the one note I kept in my slide. Case sensitive. Okay. So let us take capital A. Why? Because in the diagram we given capital A. Let us use the capital A only. Now bus later I will explain you vectors. Now as of now, A bit size is 1 bit. That's why no need to click on the bus. Okay. If you have the many bits in the A, then we can select the bit and then we can choose the MSB and LSB. That is not required as of now. Now next, another input is B. That is also input. Here you can have the option to select input or output. Since these are the inputs, that should be input. Next, sum. Sum is output. So select here output. Next is carry. Select here output. Both are outputs. Now here we have defined the ports. Now A and B are the ports and sum and carry are the outputs. A and B are the inputs. Now as I said, okay, first step capturing the specifications, and second step architecture design, logic design. You might have done previously, means while studying the digital integrated circuit, you might have studied. Okay, you might have done that. Okay, understanding the concept of the half adder and then defining the name of the inputs and name of the outputs, and then deriving the Boolean equation. Everything you might have done. Here we are assuming that we have done the specification stage, then architecture stage, then logic design stage. Now we are describing the HDL code. Now we are in the third stage of the design flow. Again, if you want to see the design flow, I will show you. This is design flow. This is already you have done in the second semester of your BTech. This. Now you are at this HDL coding style for the half adder. Now no, don't select the buses. Why? Because these all are a single bit. Click on OK. All of you done up to this? Click on OK. Now you could see it here default. Now here you have got all the inputs and outputs in default. Actually, as per the concept of Verilog HDL, okay, here we have to specify ABCD, not ABCD, AB sum and carry inside the bracket, and then we have to define input output separately. Okay. Another way of representing is inside the bracket itself, you can write input output also. Otherwise, you can put only A comma B comma sum carry inside the bracket and then write AB, sorry, input output here. That is also acceptable. But this is the standard one what automatical tool generates. What automatical tool generates. And here we have to describe the behavior of the half adder. Here we have to describe behavior of the half adder. And here you could see module, input, output, end module, all are in purple color. Am I right? Other than the black. Because of these all are the keywords. And whatever black things are there, those all are identifiers. For all these identifiers, we need to follow the same rules again.
Excuse me, sir. Hello, sir.
Yes, please tell me. I'm able to hear you.
Sir, after click on OK, sir.
Okay.
That code window will not open, sir.
Code window will open it. Otherwise, you might have done something wrong.
Project manager window came, sir. Project summary.
Okay. This
Hello,
will
sir.
otherwise
Click on your
here you could see this. You click on this, double click on this,
Yes.
then you could see this. Double click on half adder. Here you could see sources window.
Yes, sir. Yes. Open, sir.
Yeah,
Now open, sir. Thank you, sir.
Double click on this, then it will be open. Now here it will tell you, okay, various
Yeah, okay, thank you,
windows
sir.
what you could see in the tool, and then we will write the program. Okay.
Okay,
Now
sir.
at the left hand side you could see flow navigator. In the flow navigator you can see all the steps required for implementing the design on FEC. Implementing the design means writing the HDL code, choosing the device, then simulation, synthesis. See here you can see the simulation. Okay, then designing the opening the your RTL diagram. Here RTL diagram, that is schematic. If you want to see the schematic here. Okay, simulation. If you want to do the simulation here, and the simulation settings you can set. I will explain you anyway all these things. Then synthesis, then implementation. As I said, implementation will have all the steps. What are the steps? Placement, routing, floor planning. Okay, here you have seen. 1 minute. Now, okay, after synthesis, while implementation, okay, these all steps will be done internally. Okay, floor planning, placement, routing, then timing analysis, simulation, and everything. Then finally, you will get the bit file here, generate bitstream file. Okay, we can generate the bitstream file by clicking on this. Now here, okay, this will help you to understand the program, that means how to add the files or create the file. See, actually means during the creation of the project itself, I asked you to add the source file. That's right. Otherwise, there is option. If you click on this, you can see the source file. Okay, here again same steps we have to follow. Next, then you have to choose. If you forget to take the source file at the time of creating the new project, there is option to select this. And if you want to set the project setting means board, what board you are using, what language you are selecting. In between, if you have done some mistake, you can rectify all those things. Okay, language, target language, okay, and module name, everything you can see here. Double click on the project manager. Okay, project settings. And here the IP catalog, as I said, means there was one option for adding the IPs. Here you could see all the IPs, but it is not required for us. Okay, these all are predefined IPs, but you will not be using that in this training program. Now here VHD, that system design can be done using the HDL language or integrating the IPs. Like in the MATLAB there are two options. One is writing the MATLAB file and then using the Simulink, same HDL, writing the HDL program, or using the ready-made constructs available. Those ready-made constructs can be called as IPs. Now there is IP catalog. And while writing the program, if you want to see the construct templates, okay, you can use this language templates. Okay, you can find the language templates here. Then IP integrator to create. Here we have created the HDL file. Like that, if you want to create the IP integrator file, we can use this, but as for not be using this feature. Then simulation. After writing the VHDL file, we have to simulate so that we can use the simulation facility. Okay. Then RTL analysis. RTL analysis in the sense, if you want to see the number of gates and the logic diagram, everything you can see this schematic view. Okay, you can see the schematic view of your hardware. Anyway, I will show you that now. Okay, then synthesis. As I said, conversion of your HDL code into the gate level netlist can be done by synthesis. After synthesis, floor planning, placement, routing, then physical verification of everything will be done during the implementation process. After this, we can generate the bitstream file, that is what bit file, and then download the bit file onto the target will be done using open target facility. Okay, this one. But in this training program, since virtually we are doing, we can understand the simulation process and synthesis process, and implementation also we can do, but we cannot generate the bitstream file and then download onto the target. If you want to download the file onto the target, you need to connect the target. Okay. Everybody completed up? Unmute any one of you and then tell me yes or no.
Yes, sir.
Yeah, now let us write the program. What are the constructs we have kept here? Yeah, this you can write. Type this there.
The person you have called is speaking to someone else. You can wait.
Assign sum equal to A cap. Cap indicates the XOR operation. See now, I have used the capitals. So it is not changing the color. Why? Because capitals are not allowed for the keywords. All the keywords of Verilog HDL is lowercase. So we need to use only lower cases. Array equal to after this save. Here you can find the option file, save option here. See here, save the file. Now here you can see the comments. Single line comments are used. As I said, double slash indicates the comments. Now after Verilog description of half adder is done.
Sir, carry is A star B or what?
What's that?
Carry. A star B?
I did not get what you were asking. C error Y equal to A and B. This is what you were asking?
Yes, sir.
Yeah. For every statement, there should be semicolon, okay, to terminate the statement. After this, we can say we have written the HDL program. This is what the HDL code for the half adder. Now we have to simulate it. For simulation, we can use this. Before the simulation, we have to ensure the license is done or not. Okay. Now whoever is done the license can simulate it. Otherwise, I'll run the simulation. Click right click and then choose run behavioral simulation. Right click and then select behavioral simulation. If you have your license is not properly installed, then it will throw you the error. If that is installed, then it will pop up the simulation window. Based on that, now here in for me it is showing the error. Why? Error is now you can see here a valid license is not found for the simulation. Why? Because I have not set the license for my computer also. For my laptop it was done, but for this desktop also it is not done. That's why there is error here.
Sir, once repeat simulation.
Double click on the simulation. After writing the program successfully, double click on the simulation. So if the license is successfully installed, then one pop-up window will open. That is simulation pop-up.
Sir, while
Aruna ma'am?
While simulating, I'm getting a specified top module, sir.
This is the top module. If you are asking that, getting that one, right click on this and set this as the top module. Okay.
Yeah. Okay.
Select this. While simulation, select this automatically. Otherwise, right click on this and set as the top. Now license problem is there for my laptop also. Now I think some of you are having license problem. Now I will ask you to set the license. Now here type Xilinx manage Xilinx licenses. This one will come. This is for Windows 10 I am using. That way for me this option is there. Otherwise for you for Windows 7 you may find here somewhere this Xilinx. Under the Xilinx you can find manage licenses. Manage the licenses. Now after this select here manage the license path. Or load license. Click on the load license. Obtain means it will go and connect to the website. Okay. Otherwise start with trial license also it will work. For whatever it is, it will divert you. See if you click on this, it will divert you to the website. Okay. That's why I'm asking you. Already I have sent you the license file. Now I am asking you to click on this and then copy the license and save that license in one folder. Here I have saved the license in the folder. This one, all the files, okay. Now ensure that that is xilinx.lic. Then save it. Xilinx.lic, copy that after downloading and paste it in one folder. I suggest you to paste that in the Xilinx folder itself. Okay. Xilinx folder, I have pasted it. .lic and then here load the license, choose the license file, that will show you license installation was successful. License installation was successful. After successful, you have to restart your computer. Now this is the process of the license. Copy, select on the load license, then copy license, then go to the folder where you have saved the license xilinx.lic file, then open it. Then if you get this window, that is license installation was successful, then fine. After that, you can view status of the license, see the license status. Okay. Now, since this is
Sir,
Aruna ma'am,
what is that red indicates, sir?
red indicates that here this expiry date was near. Okay, that yesterday got expired. This one for all this. This is actually 1 month they will give. Okay, all this got expired. Rest everything is fine. For these features that got expired, for remaining features that is working. Okay, that is what that indicates. The Webpack, Vivado Webpack, we are using this. For the Webpack, it is done. For remaining, for these features, it got expired. Okay, Webpack, SDK, HLS, Analyzer, for all these things, it will work. Now, after saving the license file, load the license, and then see the status of the license. If you get here permanent, that is good. Okay, after this, close this window. Now let me see whether this license will work for me or not. If it works for me, that indicates for you also it will work. Yes, it is working for me. That indicates for you also it will work. How many of you got this window? After getting this window, say yes or no. Type here. No.
Yes, sir.
After successful license installation, are you getting this window? Otherwise, if you want to have your own license, what you have to do is manage licenses. Go to the manage licenses and use our license by using the option load license. Otherwise, if you want to get your own license for your account, then choose the obtain license. You can go for 30 days trial. Otherwise, the web Vivado pack, get a free license Vivado pack. This is what now you are using, and then connect to the Xilinx website. Connect now. It will connect to the Xilinx website, and then here it will ask you to fill your details. You can fill the details, then automatically license will be mailed to you. Now actually I am using the Xilinx file which was mailed to the Aruna madam, who is organizer of this workshop. Okay, I am sharing you this license. Similarly, you will get the license if you fill these details. Otherwise, create the account and then fill all the details whatever they ask. You will get the mail like this with the license file, and then you can use that license file, copy that license file, and then same procedure. Okay, go and load the license. Copy into the folder and then load the license. That will work. Now it is working for me. So now I am getting the window. If your license is not done for the software, then you will not get this window. That license is the triggering point for the simulation, synthesis, all these things. For writing the HDL program, no problem. But for simulating the HDL program only, we need the license. Okay. Now I will tell you today how to give the inputs manually. Tomorrow I will explain you how to write the test mains. Why? Because already we are running out of time. That's why I will explain you now how to write, how to give the inputs manually. Tomorrow I will tell you how to write test benches for automatic inputs Now all of you got this window after successful installation of the license, and then double click on the simulation and you will see this window. Here blue color indicates the inputs,
license file
red color indicates the don't care, that is outputs. If you gone through this step, please put it here. Yes. Yeah. Elaborate step failed because of license problem. License you can save directly in the Xilinx folder. See, after installation, you could see in the C drive there is folder with the Xilinx after installation. If you have choosing the C drive for the software installation, here you can copy just that .lic file here. Download and copy that LIC file here. That is Xilinx.lic extension file, whatever we have shared with you. Here in the Google class, we have shared that file with you. This one. Otherwise, I will share the same file with. Hello, Aruna ma'am, are you able to hear me?
Yes, sir. Yes, sir.
Yeah, you can paste that license file. You can paste the license file in the folder where software is shared.
Sir, file is nothing but I can share the Google Classroom only, sir, directly.
You can share like how we have shared. 1 minute. You are facing a problem, it seems. Now, whoever is facing the problem in downloading that file directly, they can download this RAR file and then extract the license from this RAR. Okay. Now again, I shared another file in RAR. This license file in the RAR I have shared just now. Okay. If you are facing the problem in getting this, means you might be facing the problem while saving this. That's why directly I shared you the RAR file. That RAR file is having the license file inside. So you can download the RAR file and then extract the license file and save into the folder, Xilinx folder, and then give the license to the software. Are you getting what I mean to say? Now in the RAR, you can find like this file, .xilinx.lic file. I am asking you to copy that Xilinx.lic file into the folder where your Xilinx software is installed, like this. Okay, this is the license file in my computer. Like this, save that file which is there in the RAR in the folder where the license, where Xilinx is installed, and then use the Xilinx wizard, load, copy license, and then give the license file like this. Here I have saved in the C drive Xilinx folder. So go to the Xilinx, then you could see the Xilinx.lic after saving the file. Then give it. And still, if you are facing problem, you can contact me after this class. Okay. Otherwise, you can contact the organizers also, Aruna madam and Priyadarshini ma'am. They also will help you out. Now let us proceed with this one. I hope most of you got. Still, is there anybody who is unable to get it?
Hello, sir.
Yes.
Sir, I have got all blue lines, sir, 4 lines.
What all blue lines you got?
4 blue lines.
Here, all blue lines you got?
Yes, sir.
All blue lines you mean to say? Yeah, not a
Only-
problem. Now here I will tell you, blue lines indicates the initial values. Okay, now we are going to give you the give the inputs to this design. Now I hope most of you got this window. Now I will tell you without delay. Right click on this, right click on the signal, and then here you can find the option a force the constant. Right click and then choose the option force constant. Force the constant, and since this is the binary, keep the radix binary and then force the value. Initially let us give 0, A0. Similarly for B, right click, select the force constant, again B also 0. After giving 0 0 as the input, now here you can see simulation time for which you want it to simulate. 10 microseconds or 10 nanoseconds. Here you could see picoseconds, nanoseconds, microseconds. Okay, you can select how much time you wanted to run it. Okay, you can select nanoseconds also, not a problem. Okay, and then otherwise ideally you can select the microseconds. That is the default. You can let it be default. Now here you could see 3 options. One is run all. Here run to the 10 whatever time you are specifying here, for this time it will run. Run all means it will run for continuous forever until this finish and stop system task comes. Okay, but we are not giving any system tasks in the simulator. That's why you can specify the time here for how much time you wanted to run the simulation, and then use this option to run. Here, okay, click on this, run. After running, you can see here all green colors. Green colors indicates output is generated. Now since A and B are 0 0, you could see sum is also 0, carry also 0. Now after completion of this, all of you got this. Since we given 0 0, half adder also produces both 0 zeros. Now output should be 0 0 as per the description. Now next, now let us give the A0 B1. So A is 0 already there. Now we want to give new value for the B. So again right click on the B, choose the option force constant, give the 1 now. Okay, now 0 1 we are giving, again run it. Now you can see, here you can see A is 0, B is 1. Now sum is 1, carry is 0. Sum is 1 and carry is 0. That is the behavior of half adder. If I give the A0, B is 1, sum is 1. So if you want to give both the ones, can somebody tell me if I give both inputs as 1, what will be the expected output? Now I have given B as 1 already. Now I am going to give A also 1. If I give the both ones to the half adder, what would be the output? Can anyone unmute yourself and then tell me? Hello?
Sum is
Are
0,
able to
carry
hear
is
me?
1.
Sum is 0, carry is 1. Right, great. Now I have given both 1 ones. Now run it. Now look at this. Here you can see, whenever I click on this, then A is 1, B is 1, sum is 0, carry is 1. Now this is the output what we are expecting. Now we can say half adder was described or designed by using HDL, Verilog HDL, and then simulated and functional verification also done successfully. Simulation anyway it will happen, but functional verification indicates that functional correctness of the system. Now it is acting as the half adder. How we have verified that this logic is satisfying our requirement? By giving various input patterns. Here we have given the inputs manually. Here we have given the inputs manually. But we can make this fetching the inputs automatically by writing the test bench. Tomorrow I will explain you the concept of writing the test benches. Okay. But as of now, you understand the way of giving the inputs manually and then verifying the output. Now all of you clear with this? If you are ready with this, then I will help you to design another design so that you will become perfect in the concept. And then I have given you 3 files to work on. I will explain you how to work on with that.
Sir, how to change that Z value there? Value is Z I'm getting.
Where?
In value.
Where you are getting
Under value I'm getting it as Z.
Yeah.
Here.
Where? A or B, C, D?
All four.
Where? A, B or
After
someone carry?
assigning values for A, B, I'm getting value as Z only.
Okay. No, it will not come. It will, green color only will come. Have you simulated? Means have you clicked on it? Run for simulation. Are you able to see my window?
Yes, sir.
Run for 10 microseconds. After clicking it, you will not see. If you are getting that, means there is some error.
I'll check.
Otherwise, have you given the, see here there is option force constant and force clock. Which value you have chosen?
Force constant.
Force constant you have to choose, not force.
Yeah, force constant.
Force constant. And then force value. Now I am giving 0. Okay, A I am making 0. Otherwise, let me make B0. Now we are at this one. Okay, both are 1 1. Now I am making B. Force constant 0. Then again running. Otherwise, you may face the problem here. You can see one drag option. No, you can drag towards the right hand side. Right hand side one is the latest value.
Oh.
Now 1 0 I given as the input. So if inputs are 1 0, sum is 1, carry is 0. Now if you want to see all the inputs whatever I given in a single window, then you can see here zoom in, zoom out option, zoom in, zoom out options. You can click on this zoom in, zoom out. So see everything on this single window. Otherwise click on this. Okay, here one square with that is notation. If you click on that, then I can see all the values on single window. Whatever values I given, everything will come on single window. Click on this. Now all of you got this. This is how we write the program. Now I hope you have become little familiar with the tool, and if you do practice, automatically you will become expert on this tool. It is very simple. And tomorrow I will explain you how to do synthesis, everything. Now if possible, if you are ready, I will spend another 10 to 15 minutes to explain you another program. Are you ready? Or having other commitments to go? Already many are left, it seems. Yes, it is possible to run the VHDL also. You can choose either VHDL or Verilog. How many of you done this successfully? Please, if you have done successfully, text here done. Put the text message done, completed. Sagar, good. Yes, great. Many have completed successfully. I hope you understood now how to use the tool. Okay, now I will show you how to work with the remaining labs. Okay, since means we cannot simulate everything in a day. That's why I given you some files uh, for homework. Homework in the sense you can practice it at home. Okay. Now in this R file you can see these files. I will show you once in a minute. These are the lab sources I have shared with you. In task 1, you can see these many files. I want you to simulate all these files. Only select .v. Okay, don't select TB files. TB files mean test bench files. Tomorrow I will explain you about the test bench. Now and implement the AND gate, NAND gate, NOR gate, XNOR gate. Now let us select the implementation of AND. 2 input and 1 output. Now this is the program for this. Now you have to open this Verilog file. If you want to open in the window, open with you have to choose the notepad. It will be shown in the notepads only. This is the program of AND gate. Otherwise I will explain you one way of programming. Now if everybody is ready with this, I will give you one more example. I will show you one more example. Now again, if you want to start with the new project, file, new project. Go to file and click on new project. Then next. Now we are going to implement. What do you want to implement? Half adder or full adder or basic gates?
Full adder.
Full adder. Okay, very good. Full adder. Yes. Now same RTL. Next. Here you have to add the sources. Now I am not going to add here. I will go next here. Okay, I will tell you another way of adding the sources. Okay. Here I am not adding. Previously I have added here the source. Now I am not going to add here. I will go to the next. But here I will ensure that okay, target language is Verilog and this one. Okay. Next. Now here I will choose the board is Jink board, that is Jet board. Next, finish. Now it is asking now here you cannot see any design file. Okay, am I right? Now we need to add the design file. Design file means .v file, .verilog file. Now right click on this. Now I am telling you how to add or create the source file. Now right click on this. Then here you can see the option add source. This add source is same as they're adding the source at the RTL level. Okay, this is another way of adding the design sources. Here right click design sources, right click, then add source. Here you can select add or create. Next, then you will get this window. Here this is what pop up at the RTL stage. Okay, now here select create new file, then give the full adder. Then OK, then finish. It will ask you the ports. Now I will give all the inputs. Since all the input sizes are same, I am giving you in the single entry, that is with a separation of comma. Okay, means the two signals are separated by comma. Now output, you want to give the name sum and carry only here also. Outputs, since all are 1 bit, here no need to select the bus. Now you could see here full adder. Now source is added .v file. Now double click on this, then you can see this window. Now here we have to add between the module and end module. Here we have to add the behavior. What is the equation for the sum? Here we have to use the construct assign sum equal to A XR is cap, B XR C. Again assign carry equal to, what is the equation for carry? A and B R means this symbol, okay. B and C, again R, A and C. If I want to put everything in this single bracket also fine. Now this is the program, then semicolon. Now if this equation is right, sum equal to AX or BX or C, carry equal to AB plus BC plus CA, that is the equation. Same I have written here. Here AND operation is representing by AND symbol, R operation is represented by that straight line, and XOR operation is represented by cap. Now these are the operators we use to perform the logical operations. Here what kind of logical operations are performed? AND, OR and XOR. These are the three logical operations are performed. For the sum XOR we use, for the carry AND and OR we use. After this, save the file and then run behavior. There is error. What is that error? If I want to see the errors, I have to look at this.
C in A, B, C in it. A comma B comma C in.
Yes. C in it is showing that compile error. C is not defined. Still there are errors. Now see here, it is throwing the errors nearby. Okay. It is throwing the errors to use individuals. Yes. Here in. All of you getting the same error? Please anyone unmute yourself and then tell me. Or my software is having a problem. Actually, code everything is right only.
But I am reading playing for scratch and playing. It's playing.
Sir, error same to you. We don't get any errors.
You are not getting errors?
No.
Hello? Are you getting error?
No, sir.
No, I think problem with my my computer settings. It seems that only means program everything is right only. But I am getting the error. Okay. For you, are able to simulate this?
Yes, sir.
Module
Hello?
ladder, I think it.
Are you able to simulate?
Caps. FP's caps. That's the thing.
No, that is not a problem. Yeah, this is not a problem. I think some settings got changed. Throwing this error.
Sai, door open Jay.
Yes, now it's working. Program is right only. Now you can give the values. Force constant. First, let me give A0, B1, then apply, click apply, then OK. Otherwise, directly OK also it will work. Then C also 0 I will give. That means 0, 1, 0 I am giving as input. Then run for the 10 microsecond. Yes. Now look at this. 0, 1, 0 I given and sum is carry. Sum is 1 and carry is 0. Now if you want to change the input, give C1. If I give A0, B1, C1, what will be the output? Anyone please unmute yourself and then tell me. Now see here. Carry is 1, sum is 0. If I give all ones, both sum and carry should be
1.
Force constant. Now I am giving A also 1. 3 ones. Okay. Now I could see all sum and carry also 1, 1. Now this is the behavior. Actually here we have to give total 8 combinations in order to verify the functionality of full adder. Okay, that is the pain point if you take the step to give the inputs manually. That's why test benches are written for testing the behavior of the HDLs. Now I hope everybody understood the concept, and whoever is getting confused in between, and anyway ma'am will share you the recorded one. You can go through that. That will help you to understand the concepts, and tomorrow we will learn some more concepts. Okay, how to write the program for the complex systems and how to integrate the multiple systems as one. That is what instantiations concepts we can learn, and we can see some more operators, some more constructs of Verilog HDL. Okay, further we can see tomorrow synthesis process also we could see. Okay, now let me stop for the day, and I hope tomorrow we'll start again. 2 o'clock. Am I right, Aruna ma'am?
Yes, sir. Yes, sir.
Yeah. Now, if still do you have any queries, you can put it now. Otherwise, we'll take the leave at this point. If you are facing the license problem, you can approach the organizers, Aruna ma'am. Otherwise, you can put the message in the WhatsApp group. We can help you. Okay, thank you. Yeah, Sagar, you are speaking something. Tell me.
Yeah. Is Vivado 2014.4 version is fine?
Same, that also works. That also having the same features. If latest version also having the same features almost.
Yeah.
Why I have given you this for 15 is I have that software and also 6 GB. Now latest version is having 25 GB.
Okay.
Okay, and downloading 25 GB is very difficult for you people, and that too takes a half day if you have the good internet speed. Okay. Now thank you one and all. Good day. All the best.
Thank you, sir.
Over to you, Aruna ma'am.
Thank you so much, sir. And for the participant, thank you so much for patience till 5 o'clock. Tomorrow we are going to start it kind of as early as possible.
Is the speed is enough? Aruna ma'am, one thing I want to ask: is the speed is enough, or you want me to increase the speed or slow down little?
No, if they are ready, actually the students, most of the faculties are interacting, but the students are, I don't know, very few students. So if we are once fine with the steps, we can go with a faster, sir. I think today the 2 steps are over, like how to write a code, how to give the inputs. So tomorrow we'll see how to see the RTL schematic and
Tomorrow we'll
what
go
are
to
the synthesis steps.
Yes. Tomorrow we can do that. We can see that, and we can see some more constructs, and we develop the complex systems.
Okay, sir.
And day after tomorrow we'll go for implementing the sequential and FSMs.
Yes, sir.
Yeah.
Thank you so much.
Okay, thank you.
Thank you, one and all.
Thank you, ma'am.